This microscopic view of a glowing droplet breaching a highly structured cellular barrier represents the primary technical focus for modern skincare R&D. Formulators are constantly tasked with engineering delivery systems that can replicate this specific behavior, simultaneously protecting an ingredient's stability while forcing it through the skin's natural defenses. To achieve this, chemists utilize delivery systems like liposomes, solid lipid nanoparticles, and hydrogels, microscopic carriers built to transport functional ingredients. The first mechanism is physical encapsulation. A robust lipid sphere shields the delicate inner core from external particles that cause degradation. This carrier functions as a vehicle. Navigating the skin's lipid layers, the capsule ensures the payload remains intact until reaching its targeted depth.
OnlyTRAININGS. Learn what works in the industry.
When these two mechanisms work in tandem, encapsulation provides a functional solution to both the physical degradation of the active and its inability to pass through the skin's barrier. But this theoretical logic often collapses in the laboratory. A delivery system can look absolutely perfect on paper, yet still trigger a catastrophic failure when it meets the complexity of a real-world formulation. An encapsulated active might test beautifully in a controlled, isolated environment. However, the moment it is introduced into a finished cosmetic base, it can begin to break down immediately. Choosing a carrier based solely on current marketing trends or the claims on a raw material datasheet frequently leads to these downstream failures. Encapsulation serves no practical purpose if the carrier system cannot survive the chemical and physical stresses of a commercial skincare product's lifecycle. These failures often stem from a mechanical paradox. In any delivery system, the requirements for stability and the requirements for release control pull the formulation in opposite directions. Consider an exceptionally rigid carrier matrix. It successfully locks down the active ingredient, ensuring it survives shelf life testing without leaking. But upon application, the carrier rests inert on the skin's surface, failing to release its payload and preventing its intended function. When delivery systems are treated as simple ingredient swaps, this delicate physical balance is lost, turning high-performance skincare into a process of expensive guesswork. Beyond the carrier itself, the formulation matrix acts as a hostile environment, where various chemical forces work to dismantle the delivery system. For example, mandatory preservation systems for consumer safety apply acute chemical stress to the carrier, often causing the structure to warp or prematurely leak its contents. Changes in a product's rheology, its thickness and flow, can also paralyze the carrier's mobility, preventing the active from moving through the formulation to reach the skin. These issues are often amplified during scale-up. A system that appears stable in a small lab batch can violently separate when subjected to the high shear forces of mass manufacturing equipment. Successful delivery depends on a mechanism-driven strategy, where the formulator anticipates these environmental stressors before they sabotage the final product. By mastering these physical mechanisms, formulators move beyond trial and error. This allows products to achieve targeted delivery and controlled release simultaneously. This level of technical control removes the uncertainty from stability testing and significantly reduces the need for costly adjustments during the manufacturing process. This requires a shift in perspective, moving away from chasing ingredient trends and towards a systematic engineering approach. Mechanism-first education provides the specific technical logic required to move a promising lab concept into a commercially viable, high-performance product. This is the foundation of the OnlyTRAININGS course, Active Delivery Systems in Cosmetics, Advanced Design Strategy, Stability, and Release Control. This curriculum is developed by active industry professionals who have direct experience managing the scale-up failures and preservation stresses that define modern cosmetic chemistry. Enrollment includes 6 months of full course access, a subject-specific training certificate, downloadable technical reference materials, and a forum for direct technical consultation with the experts. For R&D chemists, senior formulators, and technical managers, the goal is to stop relying on ingredient trends and start engineering scientifically robust